All right, let's take a look at practice problem 1 associated with chapter 4. The electron configuration of nitrogen, okay, remember this is represented as capital N on the periodic table if you need to look for it. But the electron configuration of nitrogen is 1s2, 2s2, 2p3. Okay, if you don't believe me, you can look it up on the periodic table. How many electrons, okay, so we're looking for a number of electrons, are present in a nitrogen atom? Okay, so we can do a couple of things here. We can do what we've done in the past and maybe pretend that there aren't any ions floating around, and we say, okay, look at the periodic table. Nitrogen is number 7. It means it has 7 protons. And so we're assuming that it's also going to have 7 electrons. Okay, so that's one way to do it. However, when we start messing a lot with ions, we're going to have to look at the electron configuration of that ion so we can figure out potentially if it's +2, +3, -1, -2, whatever it is. And so the skill we're trying to practice here is associating these superscript values with numbers of electrons. So here I have 2 electrons in the 1s, 2 electrons in the 2s, and 3 electrons in the 2p. So 2 plus 2 plus 3 equals, you guessed it, 7. So how many electrons are present in a nitrogen atom? 7 electrons. What is the atomic number of nitrogen? Well, like we just pointed out, we can find nitrogen on the periodic table. It is in fact number 7. So Z, okay, representing the atomic number, is 7. Okay. Lastly, write the orbital notation for nitrogen. Okay, so in terms of these electrons, we're going to have to deal with 7 of them. We're going to have to represent 7 electrons in this atom of nitrogen. But we're going to use the orbital notation. So in orbital notation, we're going to represent each orbital with lines, right? Horizontal lines. So, and then the 2p sublevel has 3 orbitals. Okay. Now, we're going to have to follow some rules, right? Aufbau principle, Pauli exclusion principle, and Hund's rule to associate these 7 electrons in their appropriate orbitals. So, Aufbau principle. That tells me that I have to start with the lowest energy orbital available. Okay, so that's going to be 1s, and then we have to go up appropriately in energy. And if I remember this pattern, essentially I'll be following the Aufbau principle. So I'm going to fill from left to right here. Pauli exclusion principle says that in each of these individual orbitals, you can't have 2 electrons with the same spin. Okay, the entire rule spelled out is a little bit more wordy than that, but in practice, you have to make sure that no 2 electrons in the same orbital have the same spin. They have to have opposite spin. And then Hund's rule won't apply until I get to the 2p sublevel, right? Because there are multiple orbitals in the 2p sublevel, so I'll wait to talk about Hund's rule until I get there. So again, I have to have opposite spins. So an up spin and a down spin in the lowest energy orbital that can receive them, right? So now I've dealt with 2 electrons here. Now we'll move up according to Aufbau principle to 2s. Get 1 up, 1 down. Now I've dealt with 4 electrons. I have 3 left. And so according to the Aufbau principle, I'm going to move over to 2p. But now I see a sublevel with more than 1 orbital. Okay. Here's where we start to have to use Hund's rule. It was very easy for me in these first 2 orbitals to go up, down, up, down. When I am dealing with the sublevel that has more than 1 orbital, I can't go up, down, up, down. I have to go up, 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 until every orbital is filled singly before I go back and double anything up. And so we find that I actually have to put 1 electron with up spin in each of these 2p orbitals. Now we can double check that I have the appropriate number of electrons. I have 1, 2, 3, 4, 5, 6, 7. Okay. Nitrogen is atomic number 7. It's got 7 protons. This particular version of nitrogen has 7 electrons. And this is how you represent the orbital notation for nitrogen.